Say we have here a program to compute the area of a circle, and our input data from the user is the radius of the circle. And say we declare here two variables, rad and area, which are double type. Rad holds the radius of the circle, while area holds the area value of the circle given the radius rad. So since this is double, we use the conversion specification LF to mean long float. And of course, we store in the address of variable rad the user input for radius. And then we use this formula to compute the area of a circle, and we define pi on top as a constant 3.1416. And then after that, we display on the screen both the radius user input and the value of area. So we want to display it in two decimal places. That's why we put there the .2 specification and LF, because these two variables are type double. Now, if you run this, okay, compilation is successful, as you can see here. And so we run this, say we input 2, the output is 12.57 for a circle having radius 2.0. So take note two decimal places because we specify here 0.2. Now what if we're going to separate these three portions of the program? Portion 1 is this is portion 2, and portion 3. Portion 1 is to get user input for radius of a circle. And this one, second portion of the program is to compute the area of circle given rad from the user input. And the third portion of the program is to display on screen, output the values of radius and area. Say for example, we are going to separate those three portions as three functions. Look at the declaration of a function. Okay, so this is the syntax of function definition or declaration, and it starts with return type, or the data type of the value to be returned by the function after it is called, and then the function name, and then the formal parameter list or arguments, which allows the caller of the function to give values to the function. So these are the parameters or the arguments. So these are parameters or arguments needed by the function to perform its computations. And then, just like the main function in here, main is a function that returns an integer type. So actually, we have here the return type according to the syntax. We have here return type, and if we omit this return type, just like what we did earlier, when the return type is omitted, it is by default integer. So return type integer is the same as omitting that one. So if you omit the return type, like what we did here, it is similar to having declared here an integer type. And this is the function name. So again, this is the return type according to the syntax. That is return type followed by the function name and then the formal parameter list or formal arguments. So this is return type integer, and this is the function name, and the arguments or the formal parameters, that's 0. So there are no arguments or no formal parameters for this function main. And this part here is what you call the local declarations or local variable declarations. And the second part of the function is this part here, which we call the set of statements to be executed. So again, basically, a function has two parts. The first is the local declarations or local variable declarations. And the second part is the set of statements to be executed. So just like in our example here for the main function, this is the local declarations part. Okay, so we could put a comment there. Local declarations, that's the part. And the set of statements to be executed is this whole part here. So we call this the set of statements to be executed, and this part here is called local declarations. So this is the local declaration part, and this is the set of statements to be executed. Every function has these two parts, local declarations and the set of statements to be executed. Again, this part here is the return type. Okay, that's the return type in the syntax. And then next is the function name. So the function name is main. And next is, after the function name, is the list of formal parameters or list of arguments, which in this case is 0. So there's no argument or parameter, formal parameter for this function main. But you can add some arguments there. Now, functions can either be built in. We call this also predefined functions. Predefined functions are those already defined in the C library, such as square root, square to compute the square. Say square of x, it returns x square. Say this is the square root of y, the built-in function square root of y, and this is the square of x, and many others. Okay, or the POW x y that computes for x raised to the power of y, so x raised to y. So these are examples of built-in functions, and including this one, the printf, the scanf are built-in functions available in the C library. And this built-in functions, square root, square, and POW, are defined in the header file math.h. And so whenever you use these built-in functions in your program, you need to include on top, you would say, include math.h. So this would tell the computer to import from the C library all of those built-in functions defined under math.h, so that you could use these built-in functions defined under or inside math.h, the square root, square, POW, and other mathematical functions. Now, we include stdio again for the reason that we are using the built-in function printf and scanf in our program, which are defined in stdio.h. So that's why we put there the include statement for stdio. But if you're not going to use these built-in functions, square root, square, POW, then you don't need to include that header file math.h on top. So again, functions can either be built-in or predefined functions. And these are functions defined already, ready to use, available from the C library. Another is the user-defined functions. User-defined functions are those functions that the programmer explicitly defined in the program. These functions are not available in the C library as built-in functions. So the programmer defines this or declares this or create these functions. So how do we declare or define a user-defined function? We follow this syntax. So return type function name, formal parameter list, and then this is the body of the function. And how do we call a function? Using this syntax, okay? So you use the function name, which is this, and then provide in here the actual parameter list. So take note that the actual parameter list must be equal to the number of formal parameter lists. So if there are 2 or 3 formal parameter lists separated by comma in here in the function declaration, there must be also 3 actual parameters in here in the function call. So whenever you call a function, there must first be a definition, because if there is no function definition or declaration, then the compiler will prompt you a syntax error, which tells you that this function that you call does not exist. Now for the built-in or predefined function, we don't need to have the function declaration of those built-in predefined functions in our program, because they are already available in the header file. So say for example, we call square root or square or pow this way, okay, that's how we call them. Function name is square root, and then the actual parameter is y. Now for these built-in functions, we do not need to define it in our program. We don't need to have this function definition for those built-in functions, because the function definition or declaration of the built-in functions are already defined or available in the header file, because these are built-in or predefined. So the definition is already available in the header file where these functions belong. So that's why the function definition or declaration do not appear anymore in your program for these built-in functions. But for the user-defined functions, these are not built-in functions, and so the function definition or declaration does not exist in the C library, and therefore you have to provide it or make this available in the program. Once again, say if we're going to create one separate user-defined function for this part here in the code, and that is to input the value of the radius, and another function to compute the area of a circle using this formula, and another function to display the output. So this is now our resulting program, our revised program. So compare it in here. This part here is now defined in the input function. Okay, take note, the input function declaration is this one, and that is where we place these two statements. Okay, and then for computing the area, we put it in another function which we call as compute area, and we put here the formula. And for the third part of the program, we define this, or we place this statement inside another function which we call as output. Okay, so the reason why we call this function input is because this is for user input, and this is to compute the area of a circle, and this is to output the values of radius and area. So you have to choose a function name that is related to what it does or what it computes, so that you could easily refer to that. And then instead of you having this statement in the main function, all you have to do is to call the function input, so that these two statements here will be executed. So again, we call this function call, and we call this function declaration or definition. So this is the function definition for input, for function input, and this is the function call. So when we run this program, remember that execution starts in the main function. Okay, so execution starts in here. So this is executed calling input, and so execution jumps to the function input. So from here, it jumps to here, executing the first statement here and then the second. After that, execution goes back to the main function to execute the next function call. So this is another function call. And when this function call is executed, execution jumps into this inside the body of this function compute area, okay, to execute this statement to compute for area. After this is executed, execution goes back to the main function to continue where it left and executes the next function call, which is output. So to execute this function call, execution jumps again into this function to execute the statement inside here. So since this has only one statement, this is the only statement executed. While in here, there are two statements executed. Here, there is only one, and here, there is only one also. Again, to execute a function call means that execution jumps into or inside the body of that function declaration, and it causes to execute all of the statements from the first up to the last statement inside that function. And when the last statement is executed, execution goes back to the caller of the function, which is this part in here inside the main function. And it continues to execute the rest of the statements in there. So in this way, we have done the same execution as in this program, okay? The only difference is that in the second program, we separate all of these portions, first portion, second portion, and third portion, as three separate functions. This one is function input, this one is function compute area, and this one is placed in function output. Okay, which are this? Okay, this is function input, function declaration for function input, function declaration or definition for function compute area, and this is the function definition or declaration for function output. And again, since these are function definition or declaration, it follows the syntax of a function definition or declaration, which is first, return type. In this example, the return type is void, and the function name is output, and the formal parameter list is 0 or is empty. And we don't declare local variables. We only have one statement to be executed. So this portion here, the local declarations inside the function definition or declaration, is not required. Okay, so it's just optional. If you want some local variables, if you need to declare some local variables inside the function, then you can declare local variables, and you usually place them on top before the set of statements to be executed. From the first program, we declare the two variables, rad for radius and area for the area value, as local variables inside the main function. Again, why are these two variables called local variables? Because these two are declared inside a function. If we place it outside, like in this case, for example, we place it outside, then these are now called global variables. Okay, so rad and area are now global variables because we put the declaration of these variables outside of any function. And we put that usually for global variables, we put the declaration of these variables on top of the program together with all the other global declarations, such as the header file declaration and the constant declaration. In the second program, that is what we did. We put the declaration of rad and area outside of the main function on top of the program, which makes these two variables global variables. So in here, these are now global variables, while in here, they are local variables since they are declared inside the function main. So in here, they are now global. And so instead of putting these statements in here and this one inside the main function, like what we did here. We place all of these three portions in separate functions. And so what we have here in the main function are just the function calls. Calling input so that these two will be executed, calling compute area so that this one statement, computing for area, will be executed, and calling this function to execute the printf so that we can display on the screen as output these two values. Now, when you use functions, you need to place on top as global declaration the function prototypes. We call this function prototype for function input, and this is also the function prototype for function compute area. And the third one is also this one. This line here is also a function prototype for function output. Now, not all compilers would require function prototypes. Some compilers would not require, but as a standard principle in programming, whenever you have function declarations, like in this second program, we have defined three function definitions or function declarations: input, compute area, and output. So we also place on top the function prototypes for all of this. So again, when you have user-defined function declarations or definition in your program, the standard principle is that you are going to define also on top a function prototype for each function declaration that you have in your program. Since we have here three functions, output, compute area, and input, you also need to declare on top among the global declarations the function prototype for each of the functions. So since there are three function declarations, then you need to also declare on top three function prototypes. Now, what is the syntax for function prototype? It is just this one, this line here. You just copy it, copy this one, and paste it on top and terminate it with semicolon. So take note that the function prototype statement is terminated by semicolon, while in the actual function definition or declaration, there is no semicolon in here, because if you're going to place a semicolon in here, that would give you a syntax error. It means that you are terminating the function declaration here, which is not supposed to happen, because in a function declaration, after this, you still need to have this part. Okay, so do not terminate by placing a semicolon in here in the function declaration. But for the function prototype, you need to place a semicolon there as terminator of that function prototype statement. Now, what is the purpose of a function prototype? The purpose of a function prototype is simply for compiler checking. So when you compile this program, the compiler will check if in the actual function declaration, this is what you really have in there, that the return type is void for input, and the function name is input, and that for function input, there are no arguments. Because if you're going to place here some arguments like int x, so there is now one parameter in here. In the function declaration, there is one parameter, formal parameter, but in the prototype, there's none. So the compiler will give you a syntax error. Okay, because this part here must be exactly the same. And so if there is one parameter here, then there must be also one parameter here. And it doesn't matter if the parameter name is different. Say, for example, this is h, okay? While in here, it is x. It doesn't matter if the parameter name is different, as long as the return type of the function is the same. and also the function name is the same, and also the number of parameter, it's only one, h of type integer, and in here it's only one also of type integer. It doesn't matter if the actual name of the parameters are not the same, as long as the number of parameters and the data type of that parameter is the same. So say for example, you have here two parameters. Say the second one is type character and the parameter name is ch. Then in the prototype, there must be also two. And the second one, there must be also two parameters. The first one must be type integer and the second one must be type character. Say for example, this is B. So the first parameter in the prototype must be the same type as the first parameter in the function declaration. And the second parameter type character must be the same as in here. Okay? So again, it doesn't matter the actual name of the parameter if they are different. Okay? That's the only thing that is allowed to be different. But for the return type function name, the number of parameters 1, 2 separated by comma, so there must be also 2 here separated by comma, and the first parameter must have the same data type as the first parameter here, and the second parameter here must be the same type as the second parameter in here. Okay, it doesn't matter again if these parameter names are not the same as what you declare here in the prototype. And lastly, the function prototype statement must be terminated by a semicolon, while in the function declaration, there is no semicolon. It's an error to put semicolon in here because it means you are trying to terminate the function there, when in fact you still have this part here as part of the function. So do not put a terminator there in the function declaration. Now, why do you think we declare these two variables as global variables? Why not just place them inside, just like in the first program? We have the two variables declared as local inside the main. Why do you think that this should be global in here? The reason for that is this function, erase this part. The reason for that, why we declare this as global variables, is so that these three functions, input, compute area, and output, will have access to these variables. Okay? Take note that inside input function, we use rad. Inside compute area, we use rad and area. And inside output, we use rad and area. So this rad and area here that we use in the three functions are the same variables that they access. And so these two must be global so that it is possible for these three functions, input, compute area, and output, to be able to access this. Because if this is local inside the main function, the only function that can access these variables would be the function that declares it. Main function is the owner, the sole owner of these two variables, since these are local variables inside main. And that would result to an error in here because the function input, compute area, and output cannot access these two variables because these are local inside main functions. And so if you want the variables to be shared by several functions in the program, then you have to declare those variables as global variables so that all the functions in the program can have access to these global variables. So let's try to compile this one now. Okay, so our compilation is successful. and we run this, input the radius of the circle. Okay, this is the result of calling input function. So this is executed and we input say 3. So rad now is 3. And so 3, after that, we go back to this part and continue to execute that. And this rad here is the same rad as that. So if that is 3, this is also 3 times the value of pi, and area, which is the global area, is having a value here which is equal to pi times 3 times 3. And then after that, execution goes back to the main function, and the next statement to be executed is output, and it jumps in here and it executes the statement printf. And this rad here and the area here are the same global variables that were accessed by input and compute area respectively earlier. So what happened a while ago in the second program, we declare global variables. Say this is rad and this one is area. Now since these are global variables, all of these functions, input, compute area, and output, have access to these variables. The rad in here used by input is this global variable rad, and the rad and the area used by the compute area function are these two also. And in the output function, the rad and area used by the output function are also the same rad and area, which are global variables. So when we run, when the input function is executed, when this is called, it executes the printf, prompting the user to input the radius. And then when the user inputs 3, for the value of rad, 3 is stored in here in this global variable container. And then when this is executed, the compute area function, the rad in here is this one. So it uses that value 3 and 3, and this 3.1416. So the output here is it's 28.27. So this is the value here is 28.27 for area, and so this has a value now which is 28.27. After executing compute area, output function is executed, which is this statement printf, and the one that is displayed in here is the value of rad, which is 3.00, because we specify here 0.2, meaning 2 decimal places, and the one displayed in here is the value of area, which is 28.27. So all these functions, input, compute area, and output, are using the same variables, rad and area, and so we need to declare rad and area to be global variables so that it would be possible for several functions to be able to access or use these variables.